All right, 6.3c, vectors in a plane. The first thing I want you to do is draw out this little triangle. Because remember, trigonometry means the measurement of triangles, so it's all going to be based off that triangle. So we have a magnitude of our vector. We have the direction of our vector. Now we need to get to the components. So this x component, or the I hat component, is found by magnitude cosine theta. Because cosine deals with the x. Remember going back to the unit circle, I said cosine x, remember? And then this one, the y component, or the j hat component, is magnitude sine theta. So we're going to be using this a lot. So when we have a component form, we have magnitude cosine theta, comma, magnitude sine theta. All right? So when we're talking about our vectors, and we need to get back to its components, that's what we do. All right? And then the other thing that I need you to write down is tangent of theta is equal to sine over cosine. Or it's like the y over the x. It's the opposite over the adjacent. All right? Because this is your y, this is your x. And so when we need to find our theta, that's what we use. Now, what is my inverse operation to get to theta if I tangent something? How do I get to the theta? What's the inverse? No. Arctan. It's an arctan. So I'm going to have to arctan something to get to that angle. We're going to find the direction angle of each vector. So the first vector I have is 3i hat plus 3j hat. And I always like to make a little sketch. It doesn't take very long, and I'll show you why it's kind of important once we make our little sketch. So I have 3i hat plus 3j hat. Which way is it going? Right 3 and up 3. All right, it's going right 3 and up 3. And I need to find this angle right there. I need to find that angle right there. And so I have the opposite side, I have the adjacent side, so guess which trig function I get to use? Tangent. Tangent. Opposite adjacent, it's tangent. All right, so now I have tangent of theta is equal to, what's my opposite? 3. My adjacent is 3. So 3 over 3 is also known as 1. And so this one we do know because it is on my unit circle. So when is tangent 1? Pi over 4. So theta is equal to pi over 4 radians, or in this case, we're mostly going to be in degree mode. So how many degrees is pi over 4? 45 degrees. All right. Now, let's say we didn't remember that. Let's say we didn't remember it. So if I do tangent of theta is equal to 1, and to get to theta, I arctan both sides. So if we type in arctangent of 1 into our calculators, guess what it's going to express to me? 45 degrees. All right? And so it shouldn't be too much of a shocker to us. All right, let's look at part B. So now I have 3i hat minus 4j hat. And again, I always like to start out with a picture to talk about what we're doing here. Which way is it going? Right 3 and down 4. And so there would be my vector going on. And I need to find this angle right here. And so if I need to find that angle right there, I use tangent. So tangent of theta would equal what? What's my opposite? Negative 4 over 3. And that's not on my unit circle. Can't do it, just kidding. All right, you guys have calculators. What should we do? We arctan both sides. And so when we arctan both sides, what do I get? One 3 degrees. We're going to round to 2 the whole day today. All right, so we get negative 53.13 degrees. However, that's not the answer that I'm going to receive full credit for. All right. So what we want to do is we actually want to find the angle that goes all the way around that way. Okay, we need to find that angle that goes all the way around, going from where I usually start, my initial side. So what should I do to find that angle? We add 360 to it. All right, so now we're going to add 360 degrees to it. And so when we add 360 degrees, we end up with 306.87 degrees. And that would totally get you full credit. All right. I want to make a part C. And so I'm going to say vector W is equal to a negative 3i hat minus 3j hat. And I want to show you how similar and different this one is to number 1. Which way did it go? It went left and down. All right. So it went left and down. So now I have negative 3i hat, and then I have negative 3j hat. And so I want this vector right there. So I'm looking for that angle. So I'd have tangent of theta would be equal to what? Negative 3 over negative 3, which we know is 1. Well, we did this one already. If I arctangent this, theta is equal to what? 45 degrees. But 45 degrees will not be my answer. What do I have to do? I have to add 180 to it. All right. So I actually have to add 180 degrees to this one. So I end up with 225 degrees. All right. So hopefully from there you can see why it's so important to draw that little picture. Okay. It doesn't take long, but it really it makes you understand what's going on. All right. If it's in the first quadrant, everything's good. If it's in the second and third quadrant, guess what you have to do? You have to add 180. If it's in the fourth quadrant, guess what you got to do? You have to add 360. So much, Evan.
A vector V has length 8 and direction 5 divided by 3. Find the horizontal and vertical components and write V in terms of I and J.
All right, fantastic. So I'm going to draw a picture even though it's not really necessary on this one. If I have a length of 8, I have a vector, a length of 8, and a direction of pi over 3. Okay? And so my theta is equal to pi over 3. Well, how do I get horizontal components? Remember, it's magnitude cosine theta. All right, so my magnitude is 8. And then I have cosine of pi over 3. And then comma, my magnitude of 8. And then how do I get my vertical component? Sine of pi over 3. You guys are going to be doing this a lot. Okay, magnitude cosine theta, magnitude sine theta. You're going to be doing it a lot. All right. And so you can use your calculator on this, but it has to be in what mode? Radians. Well, we don't need it to be put in radian mode. We're pretty smart. And so what do I get? Cosine of pi over 3 is 1/2. So 8 times 1/2 is 4. And then sine of pi over 3 is square root of 3 over 2. Then multiply that by 8, and I end up with 4 square root 3. However, it tells me to put it in I hat and j hat component form, or linear combination form. So now I have v is equal to 4 I hat plus 4 square root 3 j hat. All right. All right, I'd like you to find the direction for part B. Draw our picture. Which way did this go? Left and up. Okay, went left and up. All right. And so then I use tangent of theta is equal to 1 over negative square root 3. If we wanted to rationalize it, it'd be negative square root 3 over 3. Anybody do it without a calculator? Everybody use their calculator? All right, what did the calculator say? Theta was equal to what? Negative 30 degrees. However, that is not going to be the response that I accept. What do we have to do to that? We have to add 180 to it because it's in the second quadrant. So we'd end up with 150 degrees. All right. Pretty good? All right.
Find the component form of the vector that represents the velocity of an airplane descending at a speed of 150 miles per hour at an angle 20 degrees below the horizontal.
All right. Why don't I like this problem? If it told me 20 degrees below the horizontal, now we're going to be using 200 degrees because that's what it gave us. However, do we have to use 200 degrees if they didn't give me a picture? No. What could we use?
180.
Not 180 because that'd be going flat.
Oh, I need that. 160.
No, No, 160 would be 20 degrees up. 220 would be 4 degrees down. Okay, a negative 20 would also be known as what? It'd be 200 degrees that way, or it would be what? 340 degrees. All right, 340 degrees would still be 20 degrees below the horizontal, but it'd be going to the right instead of to the left. All right. All right, so let's do the components. How do I get my x component? Magnitude, cosine of, I don't want 20.
340.
I don't want 340. I'm going to use 200. Now, I could use 340 if it didn't give me a picture. Totally agree. That's why I don't really like this problem. All right. But I want you to think of it that way. All right. So then how do I get my vertical component? 150 sine of 200 degrees. All right. And then we just type that into our handy dandy calculator. My x component. 140.95. It's not 140, is it? Negative 140. All right. And then what? Negative 51.30. All right. So what this is doing is it's saying the airplane is going negative 141 miles per hour left. All right. That would be the horizontal distance. All right. And then the vertical drop is going 51. All right. 51 miles per hour that way. Okay. Hopefully it pulls up at the end. All right. All right.
An airplane heads due north at 300 miles an hour. It experiences a 40-mile-an-hour crosswind flowing in the direction north 30 degrees east as shown in figure 14.
Hey.
Express the velocity v of the airplane relative to the air and the velocity u of the wind in component form.
All right, fantastic. Okay, we need to find the airplane vector. Well, what's the airplane doing? It's going due north. So what would be the horizontal component of this airplane? None. None. It's not doing anything. All right? And so it's not going east or west. It's going due north. So that would be 0. And so then my vertical component would be what? 300. All right?
Are we supposed to know that due north is 0?
Yes. Okay. Let's put it another way. What if it said due east? Then what would be the components? It would be 300, comma 0. Okay. What if it were due west? It would be negative 300, comma 0. What if it were due south? 0, comma negative 300. All right. You do have to know your compass rose a little bit. Okay. Now I will help you out for this other part of it. All right. So now it's asking me for the velocity of my wind. All right, and it tells me I'm going to use u. Well, this says north 30 degrees east for my wind. All right, and really we don't need to know it because it actually has it on the picture. But it says north and then 30 degrees east. So that would be its 30 degrees. However, what do I need to know? I need to know this angle, which would be what? 60 degrees. Okay, I will help you out with that part. Okay, but the 300 degrees due north, like, you should be getting that part. Okay? All right, so now we're going to use 60 degrees as that component. And what would be the magnitude for this angle of 60? $40. All right, and so we'd end up having, how do I find my x component? So 40, and then cosine of 60, comma, magnitude, sine of 60. All right, go ahead and put those in your calculator. We're going to round to 2. So my x component, or my horizontal component, was 20, comma, 34.64. Okay? Which means that wind is blowing 20 miles per hour to the east, and then 34 miles per hour north. Okay, that's what it's doing. Okay? All right, let's look at part B. On part B, it says find the true velocity of the airplane as a vector. And so what that means is we're just going to add the vector of my airplane plus the vector of my wind. Okay? So I'm going to add 0, 300 with 20, 34.64. All right? So I have 0 plus 20, which would end up being 20. And then I end up having my vertical component, so I'd have 300 plus 34.64, so I'd end up with 334.64. And so that would be my vector of my airplane with my wind happening on it. All right, let's look at part C. Let's look at part C, and hopefully I can translate some lingo for you. On part C, it's saying find the true speed and the direction of the airplane. Well, what's a vector? It has what? Both what? Direction and magnitude. So what do you think true speed is? Magnitude. All right. So we need to find its magnitude. And how do we find magnitude? The distance formula. All right. So now I need to find the magnitude of the resultant. So it'd be square root of 20 squared plus 334.64 squared. And I put that in. And what did we get for the magnitude or true speed? 335.24 miles per hour. All right. And now it's asking for the direction of my airplane. Well, I always like to draw a picture. All right. So here's my resultant that I'm looking for. And so what is that resultant doing? It's going right 20 and what? Up 334.64. All right. And so I need to find this angle right there. Now, what quadrant is it in? It's in the first quadrant. So am I going to have to mess with anything? No, it's going to be nice. All right. And so what trig function do I use? Tangent. So now I have tangent of theta, which would be equal to 334.64 over 20. And then how do I get to theta? I arctan it. So when I arctan it, I get theta is equal to 8 degrees. All right. So this is what happened. This airplane with a wind of 40 miles per hour acting upon it, that's going north 30 degrees east, is really going at 335.24 miles per hour at 86.58 degrees. So how far did it get blown off course? About 3.5 degrees, about 3.42 degrees. All right. And so then that's what we have to counteract. However, is it going faster or slower? Faster. It is going faster. All right, but that airplane pilot better turn that plane. Worksheet 6.3C. Not number 7. All right, please cancel out number 7.